Hello, welcome once again. Still, this is Teacher King David. We are still on complex numbers. We're going to see square root of complex numbers. A square root of complex numbers. You know that a square root of a number is also a number. So if the square root of a number is a number, for example, square root of 4. So what is square root of 4? It is 2. So this is a number, also this is a number. If this is a real number, this is also a real number. So square root of a number is also a number, meaning that square root of a z, square root of z is also z, but you can call it z1. Square root of z is z1. So let z be a plus bi. And z1 be x plus yi. So this z is a plus bi, and z1 is x plus yi. So square root of z will be z1. So we have square root of z, which is z1. So let us square both sides. Let's square both sides. If we square both sides, it will be root z squared equal to z1 squared. So now, it means that z is equal to z1 squared, because square root of z, this squared removes what? Square root. So z equal to z1 squared. What is z? This is equality of complex numbers. What is our z? Our z is a plus bi. So now what is our z1? X plus yi squared. This is equality of complex numbers. That's what we're going to use. So now we're going to expand this one. You know that from when you have like a plus bi, I mean a plus b squared, the answer is a squared plus 2ab plus b squared. I hope you know this one. So we can use it here. So which means that a plus bi is the same as x squared plus 2xyi then plus yi squared, where a plus bi, which is this one, equal to x squared plus 2xy, then y squared, I squared. Here also you can expand as usual. When you expand, you get this one. Then a plus bi equal to x squared plus 2xy, I, here there is I. Then I squared is -1, which is negative y squared. So real part together and imaginary part together. So this is x squared minus y squared plus 2xy, I, which is equal to a plus b, I. So now, you know when two complex numbers are equal, the real part of left-hand side equal to the real part of right-hand side. Imaginary part of left-hand side equal to the imaginary part of right-hand side. So mean that x squared minus y squared equal to what? To a. Then 2xy equal to b. So we have to keep these two equations. We use it when you are finding square root of a complex number. Then, number 2, the first one I've used this one, z equal to z1 squared. So now I'm going to use magnitude. So here I've just used equality. So 2, I'm going to use the magnitude. You know that when you have the magnitude of z is the same as the magnitude of z1 squared, because if z equal to z1 squared, it means that also if I apply the magnitude, they also be equal. So now the magnitude of z is the same as the magnitude of z1 squared. From the modulus or magnitude, modulus of z power n, which is the same as the modulus of z, then power n. So it means that the modulus of z is the same as the modulus of z1, then squared. So what is z? Z is a plus b. This is the modulus of a plus bi, which is the same as the modulus of x plus yi, then squared. So what is the modulus of this? It is root a squared plus b squared equal to square root of x squared plus y squared, then squared. I think you remember how we find the modulus of a complex number. We just take this one, the real part squared plus imaginary part squared. The same applies here. The same applies to this one. So then square root of a squared plus b squared equal to this square removes the square root. So we remain with x squared plus y squared. So this is like equation 1. This is like equation 2. So now we have equation 3. So I have to combine those three equations, which is x squared minus y squared equal to a, and 2xy equal to b, and x squared plus y squared equal to root a squared plus b squared. So those are three equations we use when we are finding square root of a complex number. We use those three equations when you are finding square root of a complex number. Examples: number 1, find the square root of complex. Find the square root. Find the square root of the following complex numbers. Find the square root of the following complex numbers. We have a z equal to 3 plus 4i. We have b z equal to 1 plus I to 3. We have c z equal to -2. Yeah. We have d z equal to I. So let us try to do those examples. Those examples are going to help us to know how we can find square root of any complex number. So now, example A, we have z equal to 3 plus 4i. So we're going to find square root of this one. Meaning that from z equal to a plus bi, you see that a, it will be what? A, it will be 3. And b, it will be 4. So how do we find square root of this complex number? We have three equations. The first equation is x squared minus y squared equal to a. Then 2xy equal to b. Then x squared plus y squared equal to root a squared plus b squared. So we're going to use those three equations. We have value of a, we have value of b. So meaning that x squared minus y squared equal to a, our a is 3. 2xy equal to b, our b equal to 4. Then x squared plus y squared equal to square root of a squared. Our a is 3 squared plus b squared, which is 4 squared. Then finally, x squared minus y squared equal to 3. Let me first use equation 1 and equation 3. Then x squared plus y squared equal to, this is 9. 9 plus 16, that is 25. Square root of 25 is 5.